One of the biggest challenges for growers is really understanding what's happening on every acre of their farm. They can drive out to a field, get out, walk around, scout on foot, and they're still only going to be able to visit a very small percentage of the acres that they're growing. We can think about using imagery, whether that's coming from cameras mounted on towers, sensors mounted on equipment as it moves through the field, or things like drones, airplanes, and satellite platforms. And what that really does is help give us a comprehensive, spatially extensive view of what's happening on the farm. People think about imaging, they really think about just one kind. They think about high spatial resolution or very fine spatial resolution visible imagery, or red, green, blue imagery. So when we look at a very high resolution RGB image, we can see the world as we see it. Some of the most powerful technologies in the imaging space, though, are those that let us see wavelengths and energy signatures beyond what we can see with our own two eyes. Plants with different levels of health look different in those other wavelengths. And so if we're measuring light in these alternative wavelengths, we're actually enriching that image information with more detailed information about the plant's health.
In some cases, imagery is able to predict problems in the field, disease, pest, soil issues, prior to the naked eye being able to see it, which is also a huge advantage. If you know there's a problem coming, even though you can't see it, you can begin to prepare for it and take steps to mitigate it, correct it, or solve it, whatever it is. So imagery has helped in that way for us too. We've been able to see some things before the human eye.
A rice farmer in Japan wanted to ask if we have a sensor to measure the water level. And we don't have a sensor to measure the water level, but we had the farmer set up a yardstick, or a stick with different measurements, and we put it right in front of the camera. So when the water would rise, we could see, what the level was without having any more technology than just a stick with different markings on it.
We've done a lot of imagery projects where we're taking images of our fields. So I have a team of managers that are out looking at our crops to determine what the quality and quantity of crops are going to be like over the next 3 weeks. So I use the imagery and the drones and the planes to look beyond that 3 weeks into week 4, 5, and 6 for them. So now my manager sits down and he has his knowledge, what he's looked at, and he has the knowledge of the drone or the airplane of imagery, and he can put together a better image of what's going to happen in the future. That to me is one of the easiest ways of showing that technology is meant to work with the staff we have. It's not meant to replace them, it's meant to enhance them and give them a better ability to see things.
Farmers have been collecting data on their farms for years. This is key because all of that data over years has really formed what we think of as a grower's intuition, right? It's their understanding of their environment, the decisions they make, and all of the different sources of information that they're continually pulling together to inform their decision making. When we think about the opportunity to bring ag tech to what a grower already uses, we're talking about really allowing them to access a lot more sources of data, allowing them to access data that has a lot more precision or a lot more accuracy. Maybe it's coming from a particular sensor rather than just a qualitative observation. And this really lets a grower do more. I like to think of data science and some of the more cutting edge ag technologies as giving farmers superpowers, letting them do what they already do, but really extending and expanding their capabilities.
I feel better when I'm at a doctor's if they can show me the x-ray and say, this is a broken bone. I'm like, oh, that's a broken bone. But I don't want to have to learn how to read x-rays. We're not asking growers to become radiologists, nor should you. Growers should be able to be growers. We want to give actionable insights that allow growers to make more efficient decisions with higher confidence. What you need as a grower is a way of getting the information assembled together into a picture that makes sense to you, preferably with recommendations. That's likely to be through an app on the phone in your pocket, or something you can access through a browser, through the internet. That's a SaaS platform. Other platforms could be ones which also accept information from multiple sources, so you could plug in data from other parts of your farm. That's really what they mean by a platform.
What we do in California, we have more than 100,000 acres of farms. All the squares represent a ranch. What's green means there's no problem today. If it's red, there's an urgent issue that needs to be taken care of. So what you have here is all the circles are pumps being used right now for irrigation. The icon that represents solar panels is those big solar projects that allows them to offset the cost of energy. You see also in some cases some sensors, all of that in one place. That's the number one value. Second value is to try to recoup some of the cost. So if there's an issue, for example, here there's an alert, you can see the energy generation is dropping. We send them an alert.
I think of systems platforms in the ag tech space as really the framework by which we pull all the information together and then organize it and allow growers to interact with, visualize, and run analytics on that information so that you can really use that data to drive decision making.
In our case, we've got a device. It's sitting out there humming along. It's taking measurements every few seconds, and every 5 minutes it takes those measurements, averages them, writes them down. And then typically once an hour, it picks up the phone, calls, sends back data to our cloud, where we've got a little service that grabs that data and writes it to a database. Then another worker takes all that calibrated data and turns that into insights, which might be the frost forecast was not predicted, an hour ago, but now it seems like there's a frost. I better go alert the farmer. How big data shows up in a lot of, the tech industry is kind of unstructured data. I think what becomes challenging is, let's say you want to start pulling together all these variety trials with their genetic lineages, and let's associate these plots where they were grown with satellite data, and while we're at it, let's bring in the weather so we can figure out the growth stages. And each of those bits of data individually could be small. The complexity comes with associating all that data with each other, and there agriculture is really challenged.
Agriculture has, for the better part of centuries, been something that one does by feel. And good farmers can sort of feel it in their bones. I think what data allows us to do now is to do early pattern recognition from data sets that previously would have been improbable and certainly expensive to collect. And now with cheap sensors, with computer vision, with other mechanisms of collecting data points from the plant, environment, we're able to do things like recognize pest pressure inside a greenhouse or in a field well before the naked human eye can recognize it. But also it means that it liberates the growers from having to walk their fields all the time.
When I think of the way to use this technology, you can think of it in layers. At a starting point, you could use a provider like Ceres Imaging, and we can just give you this beautiful sense of everything going in across your field, how the plants are faring today, and what that might mean. Maybe there's a leak somewhere. Maybe you need to apply more water in one corner of the field, but reduce the pressure and the water flow in another. That's a good start point. You can build on that. Above that, you can start to think about what other kinds of technologies and sensors would you want available. Maybe you want to put in some ground sensors. And so you can build layer upon layer, starting from almost any point of the puzzle, to get more information to help you make better decisions with confidence. And then the goal is to assemble them all into a more complete picture. The more you know, the better you'll do.